Hi, my name is Lawrence Armour, and today I'm going to talk about comparative forest health between designated wilderness areas and the surrounding lands. Wilderness areas are managed as places where biological processes are allowed to occur unhindered by human interference. I internship with the New Mexico Wilderness Alliance. They help the U.S. Forest and Bureau of Land Management keep inventories of the condition of our forests and advocate for the protection and restoration of New Mexico wildland. Objective: to use remote sensing analysis of forest health to assist in communicating the effectiveness of wilderness areas protection and preserving our national forest. Plant health will be measured by the Normalized Difference Vegetation Index, or NDVI. The formula is near-infrared light minus red light over near-infrared light plus red light. These values are relative to vegetation species and region. The study area will be the Pecos Wilderness. I chose this because it's the first wilderness area designated in 1964. It would cover the Sangre de Cristo Mountains in northern New Mexico. The layers I used were Landsat bands 1 through 4, 420 meter resolution, June 2011. I downloaded these from USGS Globus Viewer. I also started with 2 vector layers, New Mexico vegetation and federal lands. I got these from ARGIS UNM site. Those I projected in WGS 84 UTM Zone 13N. First, I created a land management layer. I took the Wilderness and Forest Service from federal lands, exported the data, erased that data from the study area to create the unprotected lands, union, and then added a field called management. Next, I created a forest type layer. This had coniferous and mixed woodland, montane coniferous forests, and subalpine coniferous forests. These were extracted from the vegetation layer. This is a map of the vector layer that will be used for analysis. It is an intersection between the land management layer and the forest layer. I built a vector model so that this study could be repeated anywhere in New Mexico. It required a Python statement to populate the fields. Next, I created 3 raster data sets clipped to the study area. With the raster calculator, I created the NDVI. Then I created a true color composite and an infrared color composite to help in analyzing the data. I also built a raster model so this can be repeated per study area in New Mexico. I used the NDVI and the vector layer to create a zonal statistical table. This is useful in examining and understanding the data. The table is calculated by using the raster values contained in a polygon based on attribute. I was surprised to find that wilderness was not the highest value, and that unprotected had the highest value in the subalpine coniferous. Wilderness did have the highest minimums in the smallest range, though. Why? I examined the true color image, and part of the wilderness area was marked subalpine was actually tundra. Grasses, herbs, and small shrubs would have a larger NDVI value than barren land, but smaller than conifer trees. This would explain the high minimum values. In conclusion, just using the NDVI did not demonstrate the benefits of the wilderness areas. In the future, possibly removing elevations above 11,500 feet, or the tree line, could help remove some of the tundra vegetation. I did some experimentation with smaller areas, and it did provide higher NDVI values for wilderness areas, but it was hard to get all the designations in one study area. Maybe a mosaic of smaller areas would be a good approach. I'm always looking to improve my projects and encourage comments and suggestions. You can be contacted at leapinlaw@yahoo.com. Thank you.